I'm Scott Symington, and this is Thoughtful Beliefs. Can we tell the difference between something caused by an intelligent agent versus something caused by just nature and chance? Well, in your travels, let's say you come across these two different rock formations. Now, man in the cliff, you can explain that with nature. Through wind and water erosion, rock fragmentation, and gravity, you can see how that would create this. Mount Rushmore, on the other hand, now, that takes something totally different. There's certain things required. The artists had to make certain choices that were within a certain range as they were creating each little part of this. And all those choices had to come together in a combination to fit a pattern that's outside of the rock. It had to fit the president's faces. So all of this had to come together to hit a purpose of what they were going for. And it had complexity beyond what water, wind erosion, or any natural forces could do. We know when an intelligent agent acts. Oh, and by the way, here's the often neglected backside of Mount Rushmore. Researchers know the properties that make an intelligent agent detectable. They use this in archaeology. When archaeologists find something that's like a mortar and pestle, it doesn't look that complicated, but they know that this is actually an artifact made by people. Crime scene investigations. You got to determine, is this just an accident, horrible accident? Or was there some agency acting here with a purpose? You use this in cryptanalysis, you use this in copyright law, you use this in information theory. Researchers know the properties, and here they are, that make an intelligent agent detectable. Now, do you need to go through and memorize all this? No, a child can do this in common sense. Let's say that kid wakes up in the morning, they come to the breakfast table, they see some cereal spilled, and they see this message. Now, even when a child sees this, they know that this was made by an intelligent agent, mom. And if they can't figure this out, then there's going to be consequences to their backside. Because clearly there's purpose behind this. How do you know? Because you had to pick each letter, you had to put the letters in a specific combination, they had to fit an external pattern, the English language. It doesn't force these letters to be where they're at. It's an external pattern, and it has a specific purpose that's beyond the ability of nature to reproduce. Now, nature can make beautiful things. Look at a spiral galaxy. But the thing is, nature can produce order, like a spiral, because natural laws can lead to that. But notice, it's just a repeated pattern. It's not what they call specified complexity. There are things that are beyond the simple natural law's ability to produce. If that alphabet serial message was clearly from an intelligent agent that even a child can figure out, then compare it to this. The human DNA is a language. It's a code. And it's not just as small as that alphabet serial one. This is 3 billion letters long. If a child can look at the alphabet serial message and know it's from an intelligent agent, how am I supposed to not think the same when I see the language in DNA? DNA, well, the co-discoverer of it, Francis Crick, he was a code breaker during the war. And what we found is DNA is mathematically equivalent to code or human language. The difference being, instead of just a short little alphabet message, this message is 3 billion letters long that fits those same properties in a specific combination, all coming together, meeting an external pattern, and so on. In fact, Bill Gates said about the DNA, he said, DNA is a code. It's equivalent to a computer code, only vastly beyond anything we've ever created. And you can see this in so many areas of life, where you can take something that we see and interact with, and then decide, does it show the properties of intelligent agency, or just pure nature and chance? Oh, for example, there was an article about this K supercomputer array. It was amazing. These German and Japanese scientists and engineers took 83,000 supercomputers and put them together in what they called the K array. And they simulated brain activity for 1 second. Now, it took these 83,000 computers 40 minutes to simulate 1 second. But that's an amazing accomplishment. And people are thinking, oh, look what we're able to do. And that's true. But think about this. I did a napkin calculation on this. If you want to compare the K array to the brain, Now we're comparing just efficiency, just the efficiency. So they didn't do any of the neat stuff like emotions and free will. All they simulated was the firings for 1 second. Now, if you compare just the efficiency and us being very generous and assuming that these supercomputers could last for 70 years and that the 83,000 supercomputers are, each one of them is only the size of a brain, when you do the calculation out, what you'll find is, to compare these two, the brain is 440 quadrillion times more efficient than that supercomputer array. Think what that means. Whatever caused the brain to be is then 44 quadrillion times better funded and more intelligent than the German and Japanese scientists and engineers who put the K array together. Again, there's examples everywhere on this. The Nobel Prize winners that I've seen for molecular biology, they got it for making these amazing nanomachines. Look at what they said about it in their interviews. What they said is, all we did is we just copied some things that we saw already operating in our cells every moment. And we just couldn't do it even as good as what's already there. I'm going to leave you with an example of a molecular machine. This was done by a video from Harvard, and everything is totally accurate in it except that the size scale. They had to kind of make it wider than it actually is because just so you could see what's going on. But as you watch this video, think about the properties we know determine intelligent agencies versus nature and chance, and just see what you think.